Well, hello, boys and girls. This is Tim Ferriss, and welcome to another episode of The Tim Ferriss Show. This special episode features Dr. Mark Plotkin. He is a very popular guest, and he is back by popular demand on many levels. Mark, you can find him at Doc Mark Plotkin, Plotkin on Twitter, is an ethnobotanist who serves as president of the Amazon Conservation Team, or ACT, A-C-T. I've done a lot of work with ACT. They have partnered with roughly 80 tribes in South America, predominantly, to map and improve management and protection of roughly 100 million acres of ancestral rainforests. He is best known to the general public as the author of the book Tales of a Shaman's Apprentice, which is one of the most popular books ever written about the rainforest. His most recent book is The Amazon, subtitle What Everyone Needs to Know. And you can find my first interview with Mark where we cover his bio, his amazing resume, his adventures with Richard Evans Schultes, with indigenous tribes, everything he's learned from Western science, and the various compounds he has firsthand experience using at tim.blog/Mark Plotkin. He's also host of the Plants of the Gods podcast, through which you can learn about everything from hallucinogenic snuffs to the diverse formulations of curare. Each episode basically covers a given plant. Curare, by the way, doesn't just relax the muscles of the body and lead to asphyxiation, if used for hunting, for instance. It also led to modern anesthesia in many senses. So there's a lot to it. So check out Plants of the Gods. Today's episode focuses on how animals use medicinal plants, and it has some wild stories related to what we can learn and what we can use from the behaviors of cows, penguins, pigs, frogs, and everything in between. There's a lot of hidden wisdom in nature. And this particular audio is pulled from a chapter in Mark's book titled Medicine Quest, subtitle In Search of Nature's Healing Secrets. I read the book, I loved it, and I asked Mark if he'd be willing to record this chapter in audio to share with you all. So he made some updates, made some tweaks, he agreed, and here we are. So, with all of that said, please enjoy. This episode is brought to you by BlockFi. BlockFi is building a bridge between cryptocurrencies and traditional financial and wealth management products. They're creating innovative products to advance the digital asset ecosystem for both individual and institutional investors, and its platform now manages more than $12 billion in assets. Full disclosure, I became excited enough about this company that I ended up becoming an investor. But moving on, BlockFi, that's BLOCKFI, offers a wide spectrum of services, and I'll mention just a few here. First, their BlockFi Rewards Visa Signature Credit Card provides an easy way to earn more Bitcoin because you can earn 3.5% in Bitcoin back on all purchases in your first 3 months and 1.5% forever after with no annual fee. Second, BlockFi also lets clients, that would be you, easily buy or sell cryptocurrencies, including, but not limited to, they have a wide selection, Bitcoin, Ether, Litecoin, and PaxG, as well as USD, that's United States dollars-based stable coins, including USDC, GUSD, and Pax. BlockFi aggregates liquidity to offer seamless trade execution and pricing. BlockFi also offers instant ACH, so you can move funds onto the platform and immediately start trading. On their platform, you will soon be able to trade with ACH, meaning that you'll be able to buy cryptocurrencies directly with your bank account. And there's a lot more coming. So check it out. For a limited time, you can earn a crypto bonus of $15 to $250 in value. Again, for a limited time, you can earn a crypto bonus of $15 to $250 in value when you open a new account. Get started today at blockfi.com/Tim and use code TIM at signup. That's blockfi.com, BLOCKFI.com/Tim and code TIM. Optimal minimal.
At this altitude, I can run flat out for a half mile before my hands start shaking.
Can I ask you a personal question?
Now would seem an appropriate time.
What if I did the opposite? I'm a cybernetic organism, living tissue over metal endoskeleton. Tim Ferriss Show.
In this week's episode of Plants of the Gods, we want to look at plants of the apes, how animals use medicinal plants, and how poison dart frogs get their poison. Biologists studying animals in the wild are typically discouraged from giving their study animals names so as not to anthropomorphize them. In other words, not to think of them as friends or pets or anything like that. Jane Goodall, one of the greatest field biologists of all time, however, has always disagreed. I overheard a most interesting discussion between her and another biologist in the early 1980s. The zoologist asked, "Why do you give your chimps names? Is that really scientific?" Without missing a beat, Jane asked him, "Do you have a dog?" "Yes," he replied. "Does your dog have a personality?" she asked. "Of course," he said. "Well," said Jane, "I bet my chimps have at least as much personality as your dog." Many years later, when I was studying the history of wine as medicine in the ancient world, covered in an earlier podcast episode, I mentioned the project to Jane. "You know that drinking alcohol wasn't invented by humans, don't you?" she asked. "Chimps periodically get drunk on fermented marula fruit, as do elephants and baboons and other species as well." As an ethnobotanist who studies how indigenous peoples find and use medicinal plants of the rainforest, this was a revelation. Could some of this medicinal plant wisdom of the tribal peoples have been first learned of from the animal kingdom? In the summer of 1981, I had the opportunity to wander in the once great rainforests of eastern Brazil. The early European explorers were awestruck by the beauty and diversity of these tropical forests, which stretched in an enormous, unbroken arc from the easternmost tip of Brazil, hundreds and hundreds of miles south into what is now Paraguay and northern Argentina. However, what remains is a fragment of what once was. Small, isolated pockets of forest, home to a handful of species. More than 96% of the original rainforest cover has been destroyed. And as I wandered through those distant patches of jungle, the sounds of trucks, bulldozers, radios, and human voices surrounded me on all sides, a constant reminder that our civilization was in the final throes of obliterating the little that was left. The forest itself seemed almost empty. The large terrestrial mammals like the jaguar and the peccary that characterized the South American rainforest had been hunted out so thoroughly that I saw not even a pair of footprints. The haunting calls of the toucans and the piercing screeches of the scarlet macaws had long been stilled. Of course, these spectacular animals were not the only components that had been eliminated from these ecosystems. In the course of preparing for my trip, I had combed through the early accounts of the first European explorers who had ventured into these jungles 500 years earlier. Their reports were filled with tales of the tribal warriors who once dominated this complex and enchanting landscape. Though the jungle had been reduced by over 90% of its original range, tribes like the Botocudos and the Tupiniquin had been completely exterminated long before my arrival. So what is the medical legacy of these indigenous peoples and the once great forests in which they thrived? All of the commercial medicines derived from the rainforests of Africa, Asia, and the Americas were initially extracted from plants first observed and used by local tribespeople. No major medical compound has ever been developed from an eastern Brazilian rainforest plant, and that is undoubtedly because the Botocudos and other tribes were obliterated before any ethnobotanical studies were ever carried out. Without indigenous peoples to guide us, how best to determine which plants merit laboratory investigation? Of the 16 parks and protected areas in the country of Suriname in the northeast Amazon, north of Brazil, for example, 12 have no indigenous peoples living within the borders or nearby, a situation increasingly common in the tropics. If we're to find the new and useful compounds that do occur in the plants, how best to proceed? American aviators preparing to fly over the jungles of Indochina during the Second World War were taught that the best way to survive if shot down was to, quote, eat what the monkeys eat. While the overarching value of this advice was probably psychological, because some monkeys have chambered stomachs capable of digesting leaves that would poison or possibly kill a human, this recommendation may ironically prove more beneficial for medicinal purposes. Let me explain. We are learning that rainforest animals also know and use plants for therapeutic purposes. A most extraordinary example comes from research on an endangered species of primate in these same rainforests of eastern Brazil. In the early 1980s, Karen Stryer, then a Harvard graduate student in biological anthropology, traveled to the eastern Brazilian state of Minas Gerais to conduct research on moraquis, also known as woolly spider monkeys, the largest and most ape-like of the New World monkeys. Streyer's studies soon led her to some surprising conclusions. The diet of Moroccese proved much higher in tannins than those of other monkeys. Because tannin comprise about 50% of the anti-dysentery drug enteroviaform, the Harvard scientist wondered if the primates were in fact modifying their diets to kill parasites or control the diarrhea that often accompanies parasite infestation. Subsequent investigation revealed that the Moroccese in this forest were completely free of parasites, highly unusual for a rainforest primate. And several of these plants are identical to or closely related to species used by Amazonian indigenous peoples to control intestinal parasites. Prior to the onset of the breeding season, Streyer noted that the Moroccese diet consisted primarily of the leaves of two tree species rich in antimicrobial compounds. During that same time of year, the Moroccese visit the so-called monkey ears tree, so named because of the shape of the fruit, to feed. As a general rule, when monkeys find trees laden with edible fruit, they gorge themselves until little remains. Yet Streyer wrote that the Moroccese consumed a small portion of the fruits before departing, quote, as if they only needed a taste to be satisfied, end of quote. Once back at Harvard, she learned that these fruits are rich in stymasterol, a chemical employed in the manufacture of progesterone, which is itself used in human birth control pills. Plant hormones can affect animal fertility. Did the monkeys of this forest discover the birth control pills tens of thousands of years before their human cousins did? Primatologist Ken Glander of Duke University has spent decades studying the howler monkeys of Central America and reached conclusions that parallel those of Karen Streyer. Glander hypothesizes that the howler monkeys eat a selection of plants that allows them to determine the sex of their offspring. He notes that female howlers consume certain plants before and after copulation that they do not eat at any other time. Over decades of study, Glander found that some howlers bore only male offspring, while others produced only females, an outcome unlikely due to chance. Female sperm, that is, those that carry an X chromosome, do better than male sperm, which carry a Y chromosome, in an acidic environment, and vice versa. Could female howlers be controlling the chemistry of the reproductive tract, and if so, why? Glander suggests that plant-derived estrogen-like chemicals may be responsible. He notes that males in a monkey troop often pass more of their genes to the next generation than females are able to do. This would explain why it is often advantageous for a female to produce more males, or if there already exists an overabundance of males, why female offspring would be preferable. The study of how animals use plants for medicinal purposes has been termed zoopharmacognosy. The spelling is in the show notes. But our observation of this phenomenon is without question an ancient practice. Who has not watched a dog swallow grass to induce vomiting when the animal has eaten something unhealthy that it wishes to regurgitate? In a thought-provoking and classic research paper, the brilliant ecologist Dr. Dan Jansen of the University of Pennsylvania wrote, I would like to ask if plant-eating vertebrates may consume plants on occasion as a way of writing their own prescriptions. And sometimes animals teach us by their wisdom, but other times by their mistakes. Fatal culinary errors made by North American cows in the early part of the 20th century, for example, led to the development of several blockbuster drugs. One Saturday afternoon in February 1933, in the middle of a howling blizzard, a Wisconsin farmer appeared in the office of chemist Dr. Carl Link, carrying a bucket of blood. The man had driven almost 200 miles from his farm near Deer Park to seek help from the state veterinarian headquartered at the University of Wisconsin in Madison. It was the weekend, however, and the vet's office was closed, so the desperate farmer wandered into the first building he found, where the door was not locked, the biochemistry building. The blood in the bucket he carried would not clot. Several of his cows had recently hemorrhaged to death, and now his bull was oozing blood from his nose. He had been feeding his herd with the only hay he had on hand, spoiled sweet clover. This hemorrhagic disease had first been reported in the 1920s from both North Dakota and Alberta, Canada. While specialists determined that feeding the animal spoiled sweet clover was the cause of this malady, they were not able to cure it, nor were they able to isolate the compound in the clover that caused the problem. Their recommendation: destroy the spoiled forage and transfuse healthy blood into hemorrhagic cattle, the same advice offered by Link. Unfortunately, however, the farmer lacked an alternative fodder to feed his herd, and he was unable to perform blood transfusions in a snowstorm in rural Wisconsin during the Depression. Troubled by his inability to assist the poor man, Link mentioned the problem to German postdoctoral student Eugene Scheffel. Scheffel, an educated and idealistic fellow fond of quoting Goethe and Shakespeare, undertook the spoiled clover conundrum as a personal crusade. He and his colleagues analyzed the clover for 7 years before identifying and isolating the cause of its lethality, a chemical they named dicumarol. They correctly hypothesized that, if too much caused a hemorrhage, a minuscule amount might prove to be a useful anticoagulant. Today, dicumarol and its synthetic analogs are commonly employed in humans as anticoagulants, particularly for the prevention and treatment of pulmonary embolism and venous thrombosis. The clover analysis serves as an example of a single species yielding a multitude of useful products. Noting that one of the synthetic analogs seemed to induce particularly severe bleeding in rodents, Link proposed testing it as a rat poison, thinking it might lack the obvious dangers of more toxic rodenticides like strychnine. Research on this compound was bankrolled by the Wisconsin Alumni Research Foundation, acronym WARF. When it proved effective, it was named warfarin. Despite the bellicose connotation, the name comes from the acronym of the alumni group, not declaring war on rodents. In early 1951, an Army inductee tried to commit suicide by eating warfarin. He failed to kill himself, but did manage to induce a classic case of hemorrhagic sweet clover syndrome. The unhappy soldier was successfully treated with transfusions of normal blood and coagulants. This bizarre incident, however, led to studies and eventual approval of warfarin, then named Coumadin, as an anticoagulant for human patients. How many cardiac patients realize that their physicians are prescribing rat poison for their ills? Yet another aspect of animal behavior has led us to other therapeutic leads. A surprisingly wide variety of creatures ingest and store toxic natural compounds in their own bodies. They do this not for medical purposes, but to employ the poisons for their own purposes, either to equip themselves with the ability to deliver a poisonous bite or to deter predators from eating them. This is the case with the poisonous pufferfish. A deadly nerve poison known as tetrodotoxin occurs in dozens of pufferfish species. These fish concentrate the poison in their internal organs. Though the logical correlation is that humans would go to great lengths to avoid these toxic denizens of the deep, pufferfish are considered a delicacy in Japan. Chefs must undergo special training and then be licensed by the federal government before being permitted to prepare this sought-after delicacy for consumption. Despite the rigorous preparation, accidents do happen. Every few years, someone is poisoned. The result? General numbness, loss of muscle control, and unless treated, death. Intrigued by the numbness typical of tetrodotoxin envenomation, Japanese physicians have used it as a treatment for pain caused by migraines or menstrual cramps. Scientists were surprised to find that the deadly bite of the blue-ringed octopus also contained tetrodotoxin. Was it possible that the pufferfish and the octopus were creating the same poison? They found that neither the fish nor the octopus actually was capable of producing the poison. It was a bacterium known as Vibrio that manufactured it. The fish and the mollusk were ingesting the microbe and then storing the poison in their internal organs to deter predators. In a way, the pufferfish and the octopus had done our research for us. Of the millions of microbes or billions of microbes in the sea, they had found one of the deadliest, with potent medical applications and brought it to our attention, albeit in a most fatal fashion. The method of filching a poison from another species and using it for protection has helped us understand how poison dart frogs become toxic. Tropical American dart frogs contain myriad fascinating chemical compounds. Until relatively recently, however, we were unable to determine how the frogs made the poison. When raised in captivity, these tiny amphibians often failed to produce the same toxins. Specimens captured in the wild and placed in captivity may keep their alkaloids, that is, the chemical compounds that were so poisonous, but their progeny had fewer and fewer of these alkaloids and in some cases none. Hawaii produced an even stranger phenomenon. Poison dart frogs were released in the Manoa Valley on the island of Oahu in 1932. When the descendants of these amphibian immigrants were tested in the lab 50 years after the original introduction, scientists found two of the same types of alkaloids that are found in the original species, which is native to Panama. Another type of alkaloid found in the Panamanian specimens was entirely absent. And scientists found an entirely new alkaloid in the Hawaiian frog that does not occur in the Panamanian version. What's going on? Poison dart frog authority John Daly hypothesized that 1. The amphibians made the alkaloids themselves, 2. They made the alkaloids from something they consumed, or 3. They collected and stored the compounds from a component of their diet, much as the pufferfish does with tetrodotoxin. The answer to Daly's hypotheses seems to be a combination of all three. Some of the compounds, or their precursors, are found in poisonous insects eaten by the frog. Alkaloids are taken in and stored from beetles, ants, and millipedes. But it was not just a question of ingesting and sequestering any and all alkaloids. When ants containing two different alkaloids were fed to the frogs, the little amphibians stored only one alkaloid in their skin and apparently excreted the other. How's that for tiny chemistry? And in some instances, the frogs were observed seeking out and consuming particular species of insects that harbored compounds that the frogs typically stored in their own skin. As with the octopus and the pufferfish, these little frogs were finding new and useful chemicals in nature long before we did. In terms of intentionally using plants for medicinal purposes, the great apes of Africa are the most sophisticated members of the animal kingdom. Harvard primatologist Richard Wrangham observed chimpanzees in Uganda's Kibale forest consuming a tropical daisy called Aspelia in the early 1980s. While chimps devour mostly plants in their largely vegetarian diet, Wrangham made note of the unusual behavior surrounding consumption of the species. The leaves were carefully chosen and then swallowed. Furthermore, the primates' faces appeared to indicate severe distaste, like a child taking castor oil. Because chimps, like people, are prone to parasitic infections, Wrangham hypothesized that the monkeys were consuming these leaves for medicinal rather than nutritional purposes. Wrangham brought Aspelia specimens to the lab for analysis and received startling results. The plant contained a novel compound, which they named theorubrine, that proved to have potent fungicidal and vermicidal properties, that is, it killed bacteria, fungi, and worms. Curiously, they also learned that this plant and related species are widely employed by African peoples for a number of medicinal uses, from treating cuts to cystitis to gonorrhea. This in turn raised another issue. Was it the use of this plant by the chimps that led people to experiment with it in the first place? Ethnobotanists, scientists like me, who study people's use of local plants, have long wondered how a culture learns which species harbor medicinal qualities. While the process of trial and error clearly plays a significant role in this process, might not the plants employed by animals offer a natural starting place for experimentation? The theorubrine story had an even more bizarre footnote. When scientists retested Aspelia in the lab, they only found theorubrine in the roots of the plants, which the chimps do not eat. African, European, Japanese, and American research teams have repeatedly confirmed that the primates consume only leaves. Why then are parasite-ridden chimps eating the leaves? primatologist Michael Huffman, an American scientist who lived in Japan and works in Tanzania, found the answer in an ingenious bit of field research. Huffman and his colleagues found that the chimp's droppings often contained both aspelia leaves and intestinal worms that had been impaled on stiff, tiny hairs, known as trichomes, on the leaf surface. Though the chimps were taking the leaves as medicine, it was not a chemical that killed the parasite, but a physical remedy that simply scraped out and impaled the offending organism. Huffman christened this process the Velcro effect. Because of this research, however, scientists had indeed discovered a new antibiotic. Huffman, who was inspired to choose a career in primatology by his childhood fascination with the book Curious George, eventually collected concrete evidence that the chimps were employing other plants as chemical medicines rather than just botanical Velcro. Huffman has focused much of his field research on the Mahale region of Tanzania along the eastern shore of Lake Tanganyika, close to where the explorer Henry Morton Stanley found David Livingstone more than a century ago, and about 100 miles north of Jane Goodall's famous site at Gombe Stream. There, Huffman's guide and mentor is Mohamedi Sefu Kalunde, a soft-spoken elder of the local Watonwe tribe. Kalunde is both a skilled naturalist and a renowned herbalist. Kalunde and Huffman were tracking a sick female chimp in November 1987 when the chimp stopped in front of a Vernonia bush of the daisy family, tore off a branch, and began peeling the bark. 10 years later, Huffman still vividly recalled the events that transpired. Quote, Mohamedi said, "That is very strange. I don't know why she's eating that because it's very bitter." I asked, "Do they eat it a lot?" And he said, "No." Then I asked him if his people made use of it, and he said, "Yes, we take it for stomach problems." Vernonia represents one of the most important and widely used medicinal plants of the African continent, in fact. In Ethiopia, it is valued as a treatment for malaria. People in South Africa use it for amoebic dysentery. Tribespeople in Zaire use it for diarrhea, and the Angolans employ it for upset stomach. In Kitongwe, the language of Huffman's guide and mentor Kalunde, the name for Vernonia is Njonso, which means bitter leaf and the real medicine. As they watched the sick chimp together, she finished peeling the bark and began chewing on the stem. She did not swallow it, however, but spit out the chewed remains, only ingesting the bitter sap. Huffman doubts the sap is, quote, an acquired taste consumed for gustatory purposes. The flavor is exceptionally foul. Jane Goodall once performed an intriguing experiment, which probably has some bearing on Huffman's observation. When she gave sick chimps bananas laced with the antibiotic tetracycline, they readily devoured them. However, when she offered the same drug-laden fruits to healthy chimps, they refused them. Huffman and Kalunde continued to follow the sick chimp, which made a rapid recovery. Prior to consuming the plant sap, the chimp was suffering from constipation, malaise, and lack of appetite. A day later, she'd made a spectacular recovery. The researchers had trouble keeping her in sight as she began climbing ridges at a rapid clip. Of course, a single observation of a single sick chimp cannot be considered convincing proof in and of itself. Yet in December of 91, the research team made similar observations that added credence to their theory. Huffman and Kalunde observed another sick chimp eating Vernonia and managed to test their hypothesis. As they tracked the chimp, they collected samples of her droppings for laboratory analysis. At the time of the first collection, the stools contained 130 nematode eggs per gram. Less than 24 hours later, the egg level was reduced to 15 per gram, and the chimp had resumed hunting, an energy-intensive exercise that she appeared unable to perform the day before. When the researchers calculated exactly how much of the plant the animal had ingested, they found that her dosage was almost identical to that taken by ailing tribespeople. The period of recovery, 24 hours, was identical for both people and chimps. And though the plant was common and available year-round, chimps tended to consume it only during the rainy season, when parasite infections are most prevalent. Working with Japanese colleagues, Huffman had the plant chemically analyzed. Lab work revealed two types of chemical compounds that accounted for the plant's medicinal uses. The plants are rich in sesquiterpene lactones, chemicals found in many botanical species known to have anti-worm, anti-amoeba, and antibiotic properties. New sesquiterpene lactones found in these plants demonstrated significant activity against leishmaniasis, a common and disfiguring tropical disease, as well as drug-resistant falciparum malaria. Appropriately, the first commercial use of these Vernonia extracts may be for animals rather than people. Huffman has collaborated with colleagues in both Denmark and Tanzania to determine the efficacy of Vernonia extracts in killing a nematode by the scientific name of Osteophagostum stephanostomum, another instance in which the scientific name is longer than the creature itself. These nematodes and their close relatives cause significant loss of livestock, particularly in the tropical world. Current treatments, while effective, are often expensive by third-world standards and simply inaccessible. The quality of livestock husbandry in the tropics could be vastly improved by providing farmers with a plant they can grow and use to kill parasites effectively.
Just a quick thanks to one of our sponsors, and we'll be right back to the show. This episode is brought to you by UCAN, UCAN. What you eat and how you live, exercise, sleep, stress, all play an important role in how your body handles glucose, its main form of energy. You might think of blood sugar. That is glucose. When glucose levels are steady and you avoid spikes, you're improving your metabolic fitness. An important way to take control of your metabolic fitness is to eat and fuel with foods that help regulate blood sugar. To help enhance my own metabolic health, I was introduced to UCAN by Dr. Peter Attia, who said there is no carb in the world like it. UCAN's patented ingredient, superstarch, has the remarkable ability to provide a steady release of energy without spiking blood sugar levels. I use UCAN's energy powders and low-calorie bars to maintain focus throughout long days, for exercise, better performance when training, and to avoid fatigue without making metabolic compromises. So when I need a Scooby snack, when I need a little pick-me-up, I reach for UCAN. UCAN has a variety of different products with superstarch to help you balance your blood sugar, from energy powders and bars to granola and almond butter. There's a whole suite. Check out my favorites at ucan.co/Tim. That's ucan.co/Tim, and save 30% on your first order. That's ucan.co/Tim.
Even if developed successfully, Vernonia would not represent the first example of a useful tropical plant finding its way into the medicine cabinet of the veterinarian rather than the physician. The fruit of the betel palm is the stimulant of choice in many parts of Asia, where local people chew it wrapped in the leaf of local pepper vine. Alkaloids in the fruit provide chemical stimulus, and some claim that betel nut is as addictive as tobacco. Several decades ago, chemists isolated an alkaloid from the palm, which they call arecoline, because the scientific name for the palm genus is Areca. Although initially used by physicians as a human vermifuge, that is, to kill parasites, arecoline was eventually judged too toxic for our own species and is currently employed as a treatment for parasites in animals. Animals often prove tougher than humans do. They don't suffer the side effects some drugs cause in people. Few animals live as long as our species, so they theoretically won't incur the deleterious effects that may result from taking a drug for many decades. Hence, many of the drugs, both natural and synthetic, currently in development will eventually be used for animals instead of people, or for both. The magnitude of the veterinary market is enormous, encompassing everything from domestic dogs and cats to zoo animals to cattle, pigs, sheep, and horses that serve as the basis for agricultural operations all over the world. In fact, the annual global value of veterinary drugs is estimated to be more than $29 billion, almost $30 billion a year. Some plants harbor compounds potentially useful both for human and veterinary medicine. Fig trees dominate many tropical forests, where their fruits serve as major dietary components for both birds and primates. Chimps use the trees for medicinal purposes as well as food. In the western Amazon, the sap of one species is so highly valued as a cure for parasitic infections that it is bottled and sold commercially. The leaves of an African species are eaten by chimps in Tanzania, probably because they contain protein-destroying enzymes that kill nematodes, which, as we've seen, are the chimpanzee's most common intestinal parasites. The young leaves, which the chimps eat, contain 600% more antiparasitic agent than do the older fig leaves, which shows the chimps are pretty good botanists. Fig sap is also consumed medicinally by another large mammal, the elephant. Presumably, these pachyderms value it for its antiparasitic nature, much as local people use the plant. But fig trees aren't the only medicinal plant consumed by the elephant. In the early 1940s, scientists observed Asian elephants devouring the fruits of a legume of the genus Entada before embarking on lengthy treks, leading researchers to hypothesize that the plant may serve as either a stimulant or a painkiller, or maybe it's just pachyderm carbo-loading. For example, a World Wildlife Fund ecologist spent much of 1975 tracking and observing a pregnant elephant in Tsavo Park in Kenya. The elephant had a standard routine of covering about 3 miles a day in search of edible plants. One day, the mother-to-be walked almost 20 miles and devoured an entire tree of the borage family. The scientist had never observed this creature eat the species before or after this particular incident. 4 days later, the elephant gave birth. While this is not proof of cause and effect, the scientists soon stumbled across an interesting connection. Pregnant women in Kenya prepare and consume a tea of the bark and leaves of the species to induce either labor or abortion. When Michael Huffman related this story to his colleague Kalunde, the Kenyan replied that his grandmother had taught him that Watongwe women had used this plant for the same purpose in the distant past. Huffman noted that the Watongwe live in southwestern Tanzania, more than 100 miles south of Tsavo, implying that the custom was probably the case in more than one elephant individual or population. According to Huffman, Mohamedi learned most of what he knows about medicinal plants from his late grandfather, who gleaned insight into the potential utility of the flora by observing the behavior of the local fauna. Kalunde related the tale of a sick African-crested porcupine that dug up and consumed the roots of a local plant known as mulengelele. The little creature soon recovered from bouts of diarrhea and lethargy, often the symptoms of a parasite infection. Kalunde claimed that this led the Watongwe to begin employing mulengelele to treat parasite infestations among themselves. Hoffman cautions that this story may be merely an interesting teaching device to pass important information down from one generation to another, and adds that medicinal plant use has never before been reported in porcupines. Can we afford to dismiss this as an allegorical tale for transmitting information to children and grandchildren, or should mulengelele be investigated in the lab? This episode parallels an experience I had in the Northeast Amazon with an extraordinary tribal group known as the Maroons. When slaves were brought to the Amazon in the 17th and 18th century, many managed to escape from captivity into the rainforest. There they coalesced into tribal societies very much patterned on the African cultures from which they had been forcibly removed. They were warriors, perhaps by nature, but certainly by necessity, as they represented a severe threat to the plantation economy of the local colonies. As long as there was a home in the forest for runaway slaves, servants on the plantation were that much more likely to take up arms and/or escape. In Brazil, the Maroons managed to organize themselves into the city-state known as Palmares, which was eventually razed to the ground by white plantation owners and their henchmen. In Suriname, however, the Maroons were never conquered, and there these unique African-American cultures continue to thrive. From an ethnobotanical perspective, the Maroons are exceedingly interesting in that they have an origin in and a relationship with the forest different from the local Amerindians, as demonstrated by the ethnobotanist Bruce Hoffman. For example, they employ some plants for medicinal purposes that the Amerindians do not use. Because the Native Americans have lived in the forest for thousands of years and the Maroons have only been there for several hundred years, it's tempting to assume that the latter know much less about the forest because they're relatively recent arrivals. I came to find out that this is not always the case. I was visiting the capital of Paramaribo, sitting on the terrace of a bar overlooking the muddy brown Suriname River that flows gently past the city, With me was Chris Healy, an American raised in Suriname, who's an expert on maroon art and culture. We're speaking about the people, the plants, and the animals of the forest when he told me an exceedingly peculiar tale about the tapir, the largest mammal of the Amazon rainforest. According to Chris, the maroons claim that tapirs eat the stems of the neku plant, defecate into forest streams, and eat the fish that rise to the surface, stunned by compounds in the plants. In fact, neku, known elsewhere in Latin America as barbasco or chimbo, contains chemicals known as rotinoids that interfere with fish's ability to intake oxygen, causing them to float to the surface if neku has been added to the water in which they swim. Local peoples, both Amerindians and Maroons, take advantage of this phenomenon by throwing crushed neku stems into the river and catching the fish that rise to the surface. This plant serves as the source of rotenone, which is used as a biodegradable pesticide by organic gardeners and was in fact valued by American soldiers during the Second World War to kill mites that infested their clothing. Thinking that the Native Americans know more about the forest and its creatures than the Maroons do, I queried several Amerindian colleagues about tapirs and neku, but they steadfastly denied any connection between the two. However, several Maroons that I interviewed told me that tapirs do indeed consume neku, defecate the remains in forest streams, and so on. Does this mean that the Maroons learned of the fish-stunning capabilities of neku from watching tapirs? Or is this merely something on the order of a fanciful tale concocted to teach youngsters about the value of the vine, much as Hoffman suggested may have been the case with the mulangalele and the African crested porcupine? One of the reasons to suspect that the Maroons may well have learned from the tapir is that so much more evidence of animal use of medicinal plants has come to light since scientists began searching for it over the course of the past few decades. Chimps are the best documented group in terms of plant use for medicinal purposes, and it may be argued that their utilization of healing plants is somehow not particularly representative of the plant kingdom because these primates are so closely related to us and so intelligent. The great apes are in fact known to employ over 30 species of plants for medicinal purposes. This may well represent what scientists call an artifact of collection, meaning that the most attractive, conspicuous, and human-like animals receive the most attention. Hence, we conclude that these species use more medicinal plants than other creatures. In fact, the more we look, the more we find. Even the literature contains a long and extensive list of animals, mostly mammals, probably for the reasons noted above, consuming botanicals for purposes which are presumably therapeutic. A recent paper in Science magazine by Jacobus de Rode of Emory University noted that fruit flies lay their eggs in high ethanol foods, like the fermented marula fruits so beloved by Jane's chimps, to deter predation by wasps. Wood ants add antimicrobial resins, essentially antibiotics, from pine trees to deter microbial growth, much as the ancient Greeks added terebinth resin to wine to prevent spoilage. And sparrows and finches have been found to, in fact, add cigarette butts to their nests to deter mite infestations, because nicotine has long been used to repel insects. Another example is pigs, who are notoriously prone to parasite worm infestations. Wild boars in both India and Mexico consume plants with known anti-helminthic, that is, anti-worm properties, pigweed in India and pomegranate roots in Mexico. Yet there's an unusual twist to this pig story. In India, local people extract and use a worm-killing medicine from the pigweed roots. But though pomegranate root bark is known to contain an alkaloid that kills tapeworms, neither the pig nor the pomegranate is native to Mexico. The Spanish brought both to the New World. The pigs nonetheless selectively seek out and consume the roots of this tree as their ancestors once did in the Old World. In the course of his decades of research on tropical plants and animals, the aforementioned ecologist Dan Jansen unearthed a paper published in 1939 which noted that the Asian two-horned rhinoceros was observed eating so much of the tannin-rich bark of the red mangrove that its urine was stained bright orange. Tannins are a major component of some over-the-counter anti-diarrheal preparations such as enteroviaform. Jansen has noted that the concentration of tannins in the bladder of the rhino necessary to change the color of its urine was undoubtedly sufficient to have an impact on parasites in the creature's bladder or urinary tract. These animal-plant interactions have also been observed outside the tropics. Sean Sigstead, a laconic Harvard-trained ethnobotanist now living in Colorado, has focused his studies on the plants, animals, and peoples of the American West. Sigstead's favorite plants are a small genus of herbs known as Ligusticum, but he's not the only one captivated by this somewhat nondescript little herb. When bears encounter the plant, they exhibit peculiar behavior. Ligusticum functions, in effect, as an ursine catnip. Sigstead once observed Ligusticum roots thrown into a brown bear zoo enclosure, and a brawl ensued. The victor carried the roots to a corner of the cage, chewed them up, spit them out, rubbed them all over his face and body. Both grizzlies and polar bears have proven similarly enamored of this little plant. The Navajos of Arizona taught Sigstead that the name for Ligusticum in their language translates in English as bear medicine. These tribal peoples value this plant as a treatment for many ailments, treatments whose effectiveness is borne out by chemical analysis that documented the presence of compounds that are both anticoagulant and antibacterial, as well as other chemicals that may combat both fungi and insect vermin. To the Navajos, the bear is a sacred creature. In their creation tales, these animals are considered experts in the use of medicines. Sigstead was a bit surprised that his findings were considered so astonishing when he began reporting them in the late 1980s. After all, he told me, deer and elk have long been known to chew aspen bark, which contains compounds similar to aspirin. Why should bears be any less adept at using plants than these creatures? He also feels that people's amazement upon discovering that bears were using these plants may have more to do with our own perception and categorization. He went on to say, quote, "We tend to place a somewhat artificial barrier between food and medicine, where an accurate description is probably better described as a complex mosaic." This animal behavior noted by Sigstead has also been observed in tropical America. Quadrimundis, long-nosed relatives of the raccoon, have been observed rubbing the resin of a tropical relative of myrrh and frankincense into their fur, presumably to kill or repel lice, mosquitoes, ticks, and other noxious vermin. The Capuchin monkey of tropical America have similar practices, but are known to utilize a wider variety of plant species. Capuchins have observed rubbing 8 different plants into their fur. Of these, 4, Hymenaea, Piper, Proteum, and Varroa, rank among the most common medicinal plants used by tribal peoples of the Amazon rainforest, and at least 2 of these are used by Native Americans to treat skin problems as well. Capuchin monkeys in Costa Rica massage a mixture of the Hymenaea tree, which is a legume, and into their fur. The Suriname Maroons collect the same dried resin and make it into a tea to treat diarrhea and burn it to keep away flying insects. Laboratory analysis has revealed that this resin harbors compounds that repel insects, and anthropologists have observed these monkeys rubbing 4 other plants into their fur as well. Peasants in the region use 3 related species to repel insects and also to treat skin problems. And the trio peoples who live just south of the Maroons in the northeast Amazon have repeatedly told me they watch and learn medicinal species by observing the primates in their rainforest home. As a final example, I want to talk a bit about birds. They also appear to be making use of plants as both medicines and pesticides. Investigators were puzzled as to why penguins had almost no parasites or other harmful microorganisms in their digestive tract. Further field study revealed that penguins were consuming blue-green algae on a regular basis, and these marine organisms are often loaded with potent chemical compounds. Other birds most definitely use plants for non-food purposes, which could conceivably lead us to new and useful compounds in the process. Hawks have long been known to place sprigs of green leaves in their nest. This is important, fresh material. Here's why. Birders now note that hawks select only the live branches of certain tree species and replace the dead or dying leaves in their nests with this fresh material every few days. The red-tailed hawk, for example, uses the leaves of the cottonwood and quaking aspen, while the bald eagle, our national symbol, chooses the sedge and the needles of the white pine. In a classic study of this phenomenon, Brad McDonald of Ripon College found that 7 species of raptors, that is, birds like hawks and eagles, were using over 12 species of plants. Though other scientists have advanced hypotheses to explain this behavior, from camouflaging the nest to advertising nest occupancy, McDonald's group tested these plants in the lab and found that all effectively repel insects. In this particular experiment, houseflies. Although scientists suggest that these leaves are also noxious to other vermin like mites and bacteria. Because these birds are carnivore, the adults regularly carry dead or dying creatures to the nest to feed their offspring. The blood and decomposing flesh of these prey items attract a steady stream of insects and bacteria that have the capacity to weaken and kill the young birds. By using the green plants that they do, the adult raptors protect their offspring in what is probably the first known ornithological case of preventative medicine and maybe antibiotics as well. Compared to the trees of the temperate forest, the chemical composition of rainforest tree leaves is relatively unstudied. In McDonald's research, he noted that antibacterial compounds had already been isolated from the leaves of one of these plant species before he began his study. Similar investigations of whether tropical birds employ local leaves for repellent and/or bacterial purposes are now underway. But Neil Rettig, the foremost authority on the world's largest eagle, the Amazonian harpy, has already observed that these magnificent creatures apply live branches of the giant mora tree to their nests in a similar fashion. And what might be an insect repellent for the birds might conceivably one day prove to be a safe and effective insect repellent or antibiotic for us as well. If we can find new painkillers from frogs, new stimulants from porcupines, new antiparasitics from penguins, new antibiotics from chimps, and new contraceptives from woolly spider monkeys, what else might be out there in the forest, on the prairie, or inside the coral reef, being used by local species and awaiting our discovery of its benefit to our own species? What might have already been lost? When the Portuguese first arrived on the eastern shore of Brazil 500 years ago, the population of muriqui monkeys probably numbered in the hundreds of thousands. Now their population has been reduced to a few hundred individuals, and more than 90% of their once magnificent rainforest has been destroyed. Who knows what we lost, either in terms of the actual chemicals, the species that produce them, or the primate knowledge of how to use them, not only for their benefit, but potentially for ours as well.
Hey guys, this is Tim again. Just a few more things before you take off. Number 1, this is 5 Bullet Friday. Do you want to get a short email from me? Would you enjoy getting a short email from me every Friday that provides a little morsel of fun before the weekend? And 5 Bullet Friday is a very short email where I share the coolest things I've found or that I've been pondering over the week. That could include favorite new albums that I've discovered. It could include gizmos and gadgets and all sorts of weird shit that I've somehow dug up in the world of the esoteric as I do. It could include favorite articles that I've read and that I've shared with my close friends, for instance. And it's very short. It's just a little tiny bite of goodness before you head off for the weekend. So if you want to receive that, check it out. Just go to 4hourworkweek.com. That's 4hourworkweek.com, all spelled out, and just drop in your email and you will get the very next one. And if you sign up, I hope you enjoy it. This episode is brought to you by BlockFi. BlockFi is building a bridge between cryptocurrencies and traditional financial and wealth management products. They're creating innovative products to advance the digital asset ecosystem for both individual and institutional investors, and its platform now manages more than $12 billion in assets. Full disclosure, I became excited enough about this company that I ended up becoming an investor. But moving on. BlockFi, that's BLOCKFI, offers a wide spectrum of services, and I'll mention just a few here. First, their BlockFi Rewards Visa Signature Credit Card provides an easy way to earn more Bitcoin because you can earn 3.5% in Bitcoin back on all purchases in your first 3 months and 1.5% forever after with no annual fee. Second, BlockFi also lets clients, that would be you, easily buy or sell cryptocurrencies, including, but not limited to, they have a wide selection, Bitcoin, Ether, Litecoin, and PAX-G, as well as USD, that's United States dollars-based stablecoins, including USDC, GUSD, and PAX. BlockFi aggregates liquidity to offer seamless trade execution and pricing. BlockFi also offers instant ACH, so you can move funds onto the platform and immediately start trading. On their platform, you will soon be able to trade with ACH, meaning that you'll be able to buy cryptocurrencies directly with your bank account, and there's a lot more coming. So check it out. For a limited time, you can earn a crypto bonus of $15 to $250 in value. Again, for a limited time, you can earn a crypto bonus of $15 to $250 in value when you open a new account. Get started today at blockfi.com/Tim and use code TIM at signup. That's blockfi.com, BLOCKFI.com/Tim and code TIM.